Hi there, this screencast is about the product rule. This is something we've learned in class. It lets us find a formula for a derivative of a function, or the derivative of a function, when you can write the function as a product of two other functions. What I'm going to do today is I'm going to show you the proof of the product rule. You can see the proof is pretty straightforward. It gives you a good example of what a mathematical proof is, how it works, and how it can be very, very complete. They're supposed to be complete. So let's get going. So the product rule. So before we get going on the proof, let's just make a couple preliminary statements. So for the purposes of today, say f and g are going to be differentiable functions. And they're differentiable, we're going to say at least at a point x equals c. When you have two functions, you can define the product function this way. So f times g of x. So this is like a whole new function. F times g takes the same input as f and g. It's a product function. The product function f times g is defined pointwise. That is for each input as, so the output of f times g of x is the output of f at x times the output of g at x. This is a technical definition. It's something that we work with regularly, and we kind of don't talk about it, but I'm going to go back and forth between the left-hand side of this equal sign and the right-hand side of this equal sign once or twice. I just wanted to let you know where it comes from. All right, so here's the product rule. It says this: if f of x and g of x are differentiable at x equals c, then so is the product function. That is, if f of x and g of x are both differentiable at x equals c, then the product function f times g is differentiable at c. And moreover, the derivative of the product function at c is given by this formula. And that's the formula that we know and love. You know, in practice, we write this with a variable symbol x, not a constant symbol c. So this is probably what you're used to seeing. But if I can prove this and show that this derivative formula right here works for every c value of c, then it's going to work for the variable x. That's the idea. So that's how we get from the theorem statement to the statement that we know and love. Okay. So let's start the proof. So a proof is an argument that takes you from your assumptions to your conclusions. And in this case, here are our assumptions. We know f of x and g of x are differentiable at x equals c. So we know the following exists, or the following exist. Okay, we know f prime of c exists and equals the limit as x goes to c of f of x minus f of c over x minus c. And we know g prime of c exists. It's the limit as x goes to c of g of x minus g of c all over x minus c. Okay, and this is using the definition of the derivative. This is an alternate form of the derivative. I've mentioned it once before in a different screencast. The book uses it, the book talks about it. If it's surprising to you, go back and read the section on the definition of the derivative so you can pick up where this alternate definition is and how it relates to the previous definition, the one we're used to, the one we've talked about most. So, assuming f of x and g of x are differentiable at x equals c, we can write down these two expressions that I just wrote down. That's what we know. So now it's always good, in my experience, to write down what we want to show. We want to show that if we calculate the derivative of the product, we get f prime of c times g of c plus f of c times g prime of c. Okay, so that's the formula that we want to come up with. So let's work on it. So look at the left side of that formula. By the definition of derivative, the derivative of the product at c is going to be the limit as x goes to c of f times g of x minus f times c of, or f times g of c all over x minus c. Right, this is the definition of the derivative of the product function f times g. So let's unpack this a little bit and rewrite this as f of x times g of x minus f of c times g of c all over x minus c. Okay. Now in the next step is a creative step. So I'm going to modify my numerator here. Let me recopy. And what I'm going to do here is I'm going to subtract f of c times g of x. And then I'm going to add it back in, f of c times g of x. I'm sorry, I'm running out of room. And just notice that this and this are opposites. So they cancel out. And so really I'm just adding 0 to my numerator in a fancy way. And you'll see why that's important in a second. So now I'm going to proceed and simplify the numerator, or just reorder terms. So I'm going to write f of c, f of x, g of x. And now I'm going to move this term, f of c, g of x, up. And then now I move this term up too. And then there's that last term we began with. All right, so you can see here are the two terms that I added, and I've just moved them around a little bit. And the next thing I'm going to do is I'm going to group these and group these. And by grouping, you'll see there's a common term in each, and I'm going to factor the common term out. So I get the limit as x goes to c of g of x times f of x minus f of c over x minus c. And then over here, I have f of c is the common term, and g of x minus g of c. And that's all over x minus c. And now, just remember that I'm taking the limit of all this. So I'm going to use the limit laws and distribute this limit. So the limit of the sum is the sum of the limits. So I get the limit as x goes to c of g of x times f of x minus f of c, x minus c, plus the limit as x goes to c of f of c times g of x minus g of c all over x minus c. So let's use the limit laws once again. So the limit of the product is the product of the limits. And over here, f of c is a constant, so I can just take that out. So I have that. And now you'll notice a couple things. This right here is just the definition of g prime of c. And this right here is just the definition of f prime of c, which we assumed exist. And this right here, because g is differentiable at c, it's also continuous at c, so this limit is exactly g of c. And there's the formula we hope to get. So this proves the product rule formula that we're aiming for. And the proof is done. So that's the proof of the product rule. Study it. Make sure you understand every step. The one step that is oftentimes hard for people to remember is this creative step right here, where we're adding 0 in a creative way. I don't imagine I'm going to ever ask you to do that on a learning target quiz or anything, but just understand that you can do that, and then why somebody would do that, right? The ends here justify that means. Okay? So just make sure you're not static. That's it. That's what I wanted to show you in the screencast. Let me know if you have any questions about it. Talk to you later.